Hey guys, we're still working in 14.1 and 14.2. The last video, we learned about how to graph these sine functions. Y equals 2 sine of 2 theta. You should know how to graph that from what we did last time in the other video. Today, in this video, we're going to work on how to find the cosine, how to graph the cosine. The nice thing about the sine and cosine is they're very, very similar. And so it's not going to take us a lot to pick up on the differences here. So we're going to start with writing our basic equation, which is y equals a times cosine, make that a cosine, of bx plus k. That should look very similar to the one that we had in the y. It was y, or in sine, it was y equals a sine of bx plus k, where again a is our amplitude. We use b for the period. Remember, that's our fourth mark. The period is 2 pi over b. Remember, b has to be multiplied by x. So again, if it's x over 2, we use 1/2 instead of a 2. So there's some fractions that will be introduced. And then k is what we call the vertical shift. And we're going to go through 3 example problems to really highlight each of these issues that can come up. And so the first thing we're going to do is graph the most basic cosine and talk about the unit circle in terms of why it looks the way it does. So if we graph the traditional y equals cosine of x and we think about the unit circle here up in the top right, I'm going to create this graph real quick. Okay, so if you think about the circle up here, okay, at 0 radians or 0 degrees, the ordered pair is 1, 0. But remember that the cosine is the x value. So where sine would have started right here at 0, 0, cosine is going to start up at positive 1, or up at its amplitude. Then when I go 90 degrees of rotation to pi over 2, my x value has now become 0 while my y is 1. But I'm only focused on the x value, so I'm going to come down to 0. Then, if I keep rotating over here to pi, which will be my next quarter mark, I'm going to get to -1. So here, I want to come down to -1 when I'm at my pi mark. I'll be at -1. And then as I rotate down to the bottom, I end up at 0 again. So that's going to tell me that 3 pi over 2 should be at 0. And then when I come to 2 pi, I'm back to where I started, which puts me back up at 1. And there's the complete cycle. Now this is not a V shape. It is still a curve like the sine wave was. And so it's going to curve sort of down like this and back up. Now if we try to follow this backwards, it should follow the sequence in the exact opposite order. And so since we're up here at 1, the next logical place would be to go to 0. If you think about it here and we're going this way, the 3 pi over 2 is the same as a negative pi over 2. That would put us at 0. Our next mark, if we're following this pattern, okay, we're basically starting right here and working our way backwards. We went to 0. Now we should be at -1. So we'll be down here at -1, then back at 0, and then at -2 pi, we'll be back up at +1 to produce this wave that we see. It's a repetition. Again, this is used for modeling. Sine and cosine waves are used for modeling electricity, light, the phases of the moon. It can be used for that. Anything that is periodic or repetitive in nature can be modeled by a sine and cosine wave. This is a really, really powerful thing. Now, one of the most interesting things about a sine and a cosine wave, so I'm just going to draw what we did last time, the sine wave on top of this. It would have looked a bit like this. And the thing is that if you take this blue graph or the black graph, it doesn't really matter. If you were to shift one of them over 1 mark to the right, let's see if I can do it. No, it won't let me move the, hoping it would let me move just the one. It won't let me do it. But if you were to slide one graph over on top of the other, they would line up perfectly. So let's just remember this was the blue one is y equals sine of x. So they are very, very similar in nature and properties. All right, so that's our most basic cosine. It is going to start up at its amplitude, go to 0, down to the negative amplitude, back to 0, and back to the top. That's the traditional cosine wave. Now let's look at some of the issues that can come up with it along the way. So let's take a look at y equals, let's say, 2 cosine of 2x. So the first thing we're going to do is come in and create our amplitude here at 2, right? There's my amplitude. That's how high and low this is going to go. So I'm going to go up to 2 and down to negative 2. Now I know that my cosine will start at its positive amplitude unless it's negative. So I'm going to put that dot there. I know I'm going to go out 4 marks, same as always. Okay. Now what that 4th mark is still to be determined. We'll get that here in just a minute. But I like to focus on the fact that cosine waves all look the same. The labels are what we have to come up with. Like the fact that this goes up to 2, that was for me to figure out. But I know that the cosine is going to go there to 0, to the negative amplitude, back to 0, and to the positive amplitude. And it's going to create a curve that looks something like this. And if I were to continue it backwards, again, I would encourage you to put the dots down just because I am not the best at this. And man, when I don't have the dots, it can really make it a little tricky to get it to line up right. So just try to make sure that you're getting, and these go on forever and repeat. The last thing that we have to do is figure out what the period is. Now the period is the 4th mark when we create these, and all we have to do is take 2 pi and divide it by the number that's multiplied by x. In this case, it's 2. Makes that pi. I'm going to put a pi right there and a negative pi right there. This is what I'm going to ask you to produce for your cosine graphs today. They will not all look like w's. All we have to do is make it negative and the w gets flipped. So let's look at an example like that. So let's take the y equals negative, we'll just go negative cosine of x. Let's put it over 2. Yeah, we'll just go there. We'll just go ahead and do that one. So the first thing we recognize is, yes, its amplitude would be 1, but because it's a negative 1, we're going to have to reverse our dots, okay? Where they're all going to be sort of backwards in terms of how we build it. We're going to start not at positive 1, but we'll start at negative 1. Let me grab a different color here. Here we go. So we're going to start down here at negative 1. Now normally we would have started up here at positive 1 and gone down. So we're going to start at negative 1 and come up to 0. Then where we would have been at negative 1 will be at positive 1 and then back down. You can see that pattern there. And my dot's coming back. Once you've graphed and really come to understand the sine wave, cosine wave really isn't any different. It's just about where do you start in the cycle. Starting at the peak versus starting at the center point is the big difference. All right, and then we need to label the period. Remember, it's 2 pi divided by the thing times x. Well, x is being divided by 2, which makes this the equivalent of 1/2 times x. So I'm going to put a 1/2 there, which I know I have to flip in times by 2 over 1. Now keep in mind, guys, this is going to happen. You're going to see a pi over 3 or a theta over 3, stuff like that. So you're going to have these fractions that you flip. When you flip them, it's really just a multiplication by the denominator. We end up with 4 pi. So we're going to call that 4 pi over here and negative 4 pi over here. Okay. and we kind of just run from there. That's it. Okay. One last question, and that's dealing with our vertical shifts. Let's go ahead and do y equals, let's just really mix it up. -3 cosine of, let's go 4x minus 2. All right, so when we have that vertical shift going on in any way, shape, or form, the first thing we want to do is come in and deal with that vertical shift. Okay, so down 2, I'm going to go to -2, and I'm going to draw a horizontal dotted line. Remember, this is my new midline or center line. Okay, that's where everything's going to be measured from. So now when I go to do the amplitude, okay, -3, it's down 3 from there. So that's actually going to put me at -5 and at +1. Okay, those are the two places where my graph is going to reach to. So I'm still going to go out my 4 marks to the right. 1, 2, 3, 4. And you can label the period as soon as you want. Normally I produce the graph and then I come in and label the period. Feel free to label the period first. In this problem, it'd be 2 pi over 4, which simplifies to pi over 2. I'm going to label this pi over 2 and negative pi over 2. All right. And when it comes to doing the actual graph, got to remember, okay, cosine starts at its amplitude, which would mean it would start at 1, but because it's a -3, it's going to start down here at -5. The next dot will be on the center line. Now the center line got shifted down here to -2, so I'm going to put the dot there. Then at my next dot, I should be at the other amplitude. I started at -5, so now I'm up to +1, back to my center line, and then back down to -5. If I follow that pattern here to the left, I should have a dot there, there, and there. As long as you follow the same consistent pattern in terms of building these problems, you should be just fine. But this is really as messy as it'll get. You're going to have questions possibly from time to time, and that's totally okay with me. I should show you now how you can get an image of it on Desmos, but it's not a perfect science. And so when you go to Desmos and you try to type these in here, you're going to just find some issues. So for one, we are in radians because we're using pi. So here I actually would want radians. The next thing is when you graph y equals -3, we're going to go cosine. So let's grab our deal down here. Cosine of 4x. They might use a theta, but you have to use your x, and then -2. Okay. Here's our graph. Well, you're probably going to have to zoom out a little bit. I mean, there's some things that you can get from it, but I don't know that you're going to be the happiest with it. Okay. For instance, you got to figure out where the center line is. Now, if you pay close attention, you can kind of figure out that it's at -2 in this. So if you came and graphed like y equals -2, and you maybe hold down here to get it to give you a dotted line option, maybe that line option. Okay. Then I guess, okay, well, I can see the dot at the center line there, and I can come try to figure out, but guys, this is not, like, we're not labeling all these points. We want to know where that is, and we probably want to know where that is, and that is, but this is all that I'm drawing there. You'd have to come in and maybe change your x-axis to only go from negative 3.14 divided by 2 because it was pi over 2, and positive, I guess I could type in pi divided by 2, and we'll do that over here. hit the pi key there. This would allow me to see exactly what we saw on our graph. But man, you're going to have to get really picky about stuff in order to make it look good. And I just don't know that you're going to really be that happy with it. So my encouragement to you is just go through the system. Calculators, graphing calculator can help, but only if you really understand the systems that it uses. Otherwise, just the same thing that we did with sine. Good luck. We'll see you during office hours.